So welcome to episode 17. So this video I'll be introducing you to graphics hardware and software so that you understand the system in which the CAD modeling is built on. So I hope you enjoy it. Next slide. So for aims and learning outcomes, I hope to provide an introduction to graphics hardware and software to aid the understanding of CAD so that you have a better appreciation of the method in which to create the 3D models for 3D printing. For the learning outcome, I hope you'll be able to list and describe and maybe even draw the basic components of graphic hardware and software using a framework so that it would be easy for you to remember it. So yeah. So let us begin with a simple framework first. So there are three components that I want to tell you about. It's the input device, the computer, and the output device. Basically, for the input device, you have your mouse and keyboard, usually what you input to the CAD software. And now these days, you could probably even have a 3D scanner so that you can scan your real life object and then it appears as a 3D model onto your computer. So your computer is basically where all the programs are stored and installed. So you usually want a pretty good computer for this. And the output device, currently it's mainly on a computer screen in which you can view the 3D model. But as we move on, you can see that some people has a 3D printer connected to their computer. So whatever you 3D model onto the software, it can print it out in real life. So let's move on to a more detailed framework of this. So this is the conceptual framework that I want to share with you to give you an understanding on what goes behind the CAD software and the computer. First, you have the device handler. Basically, this handles all the input devices you have, whether you're going to plug in a mouse, a keyboard, a 3D scanner, and all these commands that you press on these input devices goes through an interface, which is most likely the screen that you're seeing, and this interface interacts with the application program. The program could be on a 3D modeler, or it could be a support generator, or it could also be an STL model editor. So behind the application program, what that is powering it, there is the graphics, and there is also a geometric call on how the program actually creates the shape. And lastly, there is also data files and other data formats that the application must be able to read and process. And once it's done all this, it inputs it out to an output devices. So in the next few slides, I will go through each of these boxes a bit more detailed so that you have a better understanding of this conceptual framework. And hopefully at the end of this video, you'll be able to list and describe what a graphics hardware and software is using this framework. So let's go on to the next slide. So for the input devices, I want to talk about what can you actually input to a computer, what are the normal inputs commands that you'll face. So first would be a request base. So basically this is an input command that you are forced to input because the program requires a certain information before it can continue to the next step. An example would be if you want to extrude or elongate a shape, so the computer might ask you on what is the actual value in which you want to elongate this shape by before the program can process your command. So the next type of input command would be called an event base. Basically, this is something that you want to change. So something, for example, you want to change the units in which you are 3D modeling your 3D model. So this creates an event-based input command. Next would be a sampling-based input command. So what this is that imagine if you want to draw a square, and imagine if you can click on the diagonal and you can drag the square whether it is like very big or very small. As you are dragging this box, basically it's called a sampling based input command. So I think these are mainly just theory, so it's just good to know. So yeah, let's move on to the next slide. So next we have the application, programs, and interface. Basically, applications are like what you can do with this software, whether it is to create the 3D model, whether it is to create the supports needed for the 3D printing, whether it is to edit the STL file that you have got from somewhere. So the interface for such 3D modelers are mainly icons based. We click and then you just draw. And then another type of 3D model that you might find is a text command, in which that you have to type in the command by text before the function appears or the tool appears. Next type of interface for like support generation. Some of the supports can be created by just click and place the support where you want it to be, or sometimes you might have to specify the overhang angles in which like any angle which is below whatever you specify, a support will be automatically generated onto the model. So basically these are the applications and interface. Let's move on to the next slide. So next we have the graphics engine. Basically there are mainly two main types of graphic engines. One is raster, the next is vector. So raster graphics are mainly composed by pixels, as you can see from the picture. And vector graphics are composed by mathematical relationships. So I think either one is alright, but for the difference is that in vector case, the image appears like very smooth no matter how much you zoom in and out, but both of them is equally fine really to me. So yeah. So types of geometric call. So basically this is how your 3D modeler goes about creating your shape. One way you can go about it is by using a constructive solid geometry, CSG. Basically what it does is that it subtracts or add shapes together to form your final shape, as you can see from the picture on the left. Another way a 3D modeler could go about creating your shape is by using the boundary representation. So basically this requires the user to specify each of the boundaries. So basically the user has to specify the square on each face before, and to specify how each face are joined to each other. So it's like the top face is joined by the four other faces from the edges of the square. So each of this method has its strong points and weak points, but it is really based on personal preference. So this is normally the main differences when you want to buy different 3D CAD models, that you have to take note on how the CAD models are run, what is inside the geometrical, whether is it a CSG type of 3D modeler or a boundary representation type, because this would seriously have an impact on the interface and how you go about using the 3D model. So yeah, let's move on to the next topic. So data files. I think I usually get a lot of questions on what type of data files can be used and cannot be used. So let me just go through them. So basically for CAD 3D model files, there are many different types of files that are unique to each software. Like probably Autodesk has their own CAD file type and SolidWorks has their own file type. So these are all very unique, but thankfully that each of these CAD software does allow you to export the model using a data exchange format, such as the step file, the IGS file, or the Parasolid file. So basically what this does is that you can save your model as in any of these three models file type, and hopefully you'll be able to open these 3D models using another CAD program. Another common data files is the STL file type for 3D printing. So basically this is just a file type that composes of triangles. So yeah, let's go on to the next slide. So once again, if ever you want to learn more about each point, I suggest you just Google it. So yeah. So lastly we come to the last topic on the output devices. So basically, the most common output device you see is the computer screen. So one questions that you usually get is that how actually does a 3D models get displayed on a 2D screen? So this question, the answer to this question is basically what you're seeing this 3D model projected on a 2D plane. So you might create a 3D model, but if you want to add something on one of the faces, what the computer does is that the computer rotates the 3D model until that you are facing like perpendicular to a certain plane that you want to edit on. So this is how the 3D model is worked on a 2D computer screen. So I think I would explain this question on a later video probably. So because it's a bit tricky. So another output devices would be the 3D printer. So yeah, let's move on to the next. So we have reached to the summary. So hopefully at the end, hopefully now you're able to describe the basic components of graphic hardware and software using the framework I just told you, which is shown on your screen here. So thank you for listening to this episode, and we'll be moving on to the references. So for the references, I would like to thank Professor Toshu Beng and Professor Lee Yong Sui for their module in my undergrad course. It's called MP3005 Computer Aided Design from Nanyang Technological University. Basically, what they taught me formed the main idea of what this video is about. So I'd like to thank them a lot, especially on this framework. The idea of it came from this course that I took. So yeah, next. So my next reference would be on the 3D printer icon and the computer display icon that I took from the web. Then we have the keyboard icon and the mouse icon that I took from the web as well. So continuing down the list of icons are the scanner and the CPU icon. So once again, I would like to reiterate that I really thank all the references, because without all the illustrations, without all the ideas, this video would not be possible, and it would have taken me a longer time if they were not readily available. So thanks once again. So last but not least, I would like to thank the reference for the raster and vector graphics on how it works. The illustration is good. Then the illustration for the constructive solid geometry, and also the illustration for boundary representation. So once again, I hope you enjoyed episode 17 and you learned a bit more about what actually happens in a CAD software, CAD system. So yeah, thank you once again, and hope you can't wait for the next video.